Director of the VLab. Welcome to the June edition of the VLab Forum. And as we used to be our summer solstice edition coming up on Friday, the summer solstice. So today we are very pleased to have Joe Zajic, affiliated with the Office of Observations, right, Joe?
That's correct.
That's right. And we're going to hear about a really cool application, the Mesoscale Domain Scheduler tool that was prototyped by Joe and his group in order to take advantage of the new capabilities of the GOES-R satellite with regard to mesoscale sectors. It's a whole new paradigm change, and it requires a new sort of process or processes in order to request the positioning of these sectors that was never seen before until the arrival of the GOES-R series. So Joe and his group have developed this prototype, which has been tested and used and is being used. It was developed using the VLab itself, which is an interesting part of this in and of itself. But I'm going to let Joe go ahead and describe what's in the slides. These were presented at a technical review, and that I attended and was extremely impressed with them. So I thought they were really worth sharing with the VLab Forum audience. So reminder that our format is roughly about 30 minutes of content going through the slides and followed by a Q&A of about roughly 30 minutes. When we get to the Q&A, please use the raise your hand feature of the GoToWebinar. And John Chattel, our technical production manager here at the VLab Forum, will unmute you so you can ask your question directly to Joe. Or you could use the chat feature and type in a question, in which case either myself or John will relay that question. Well, actually, Joe's in the room here, so he could read the question himself, and anyway, you could use the chat feature. Also, reminder that these sessions are recorded, and this one will be uploaded to the VLab Forum website shortly after conclusion of the session. So without further ado, Joe, take it away.
All right. Hello, everybody. And I'm here with Eric Galat, who handles the operational coordination side of the Mission Manager activity. We're going to talk today, as Steve said, about the Meso tool. I took a look at the people listed on the audience, and I think it's going to be interesting because it looks like everybody knows a little more than me on some part of this. So hopefully we'll put the slides together and it'll be a nice integrated view for everybody. All right, let's go to the next chart. We're going to talk about this tool called the Meso Mission Manager, or the Meso Domain Scheduler, what its context is, mission context, what languages, dependencies, software stuff, the environment. We're going to talk about the virtual lab and the parts of it that we used and how we thought that it was a really fine application environment for rapidly getting this capability integrated into the workforce. And then we're going to talk about how the application integrates into the VLab and provides capability for use. All right, next chart. Okay, the tool is a task scheduling tool. GOES 16 and GOES 17, as you know, that's the $12 billion worth of new geostationary satellites that Greg Mant launched for the Weather Service over the last couple of years. And those, the primary instrument on GOES 16 and 17 is the ABI, Advanced Baseline Imager, and it has 16 spectral bands and images the full disk normally once every 10 minutes. It images CONUS every 5 minutes, and then it has this unique feature of 2 independently targetable 1,000-kilometer by 1,000-kilometer mesoscale images that are imaged at once every minute. So the trick is I get 2,000 by 1,000-kilometer images. Where do we put them? And how do we decide where the workforce best wants these images to be placed? And the legacy CONOP for doing this was, what the Weather Service had in its history was the RSO from Goes NOP, which was, Eric, was 7.5 minutes, and you either got it or you didn't. So the notion of having to target it, and at this point with Goes 16, 17, 4 independently targetable 1-minute imagery areas, it's a whole new game. So to facilitate the scheduling and decision making for that, our team, the Tower S team that supports the Galapagos observations, determined that it made sense for there to be a GUI tool that provided some interactive visualization and scheduling for coordinating with the SDM and with NESDIS. And we also determined that we didn't really know what the CONOP 5 years or 10 years from now was going to be, so we wanted to do any kind of tool that we did in a very agile, bleedingly forward type of approach, but because it's being used for operations by operational people that don't have time to mess around with software that doesn't work, it actually had to kind of be seamlessly available and reliable and all that kind of stuff. So we came up with this single-page VLab application. It's all open source. There's 40 components and 6,927 lines of JavaScript code for those of you that are interested in that stuff. And there's 2 versions of this tool. There's the private version, which is private amongst all 3,000 of our forecaster friends. And then there's public, which is available to the other 300 million stakeholders. The public version allows people to look at where the mesos were and or are going to be. The private version actually allows you to put in requests to cause where they're going to be. All right, next chart. This gives forecasters, as I said, the ability to visualize and request tasking. The things that can be requested, we can have, an individual mesoscale targeted. You'll get a 60-second, an updated image every 60 seconds over 1,000 by 1,000 kilometer click. For reference, 1,000 by 1,000 kilometers is sort of like New England, right?
It's bigger than that. You can go New England all the way down to like North Carolina.
Okay, so Northeast, that kind of shape.
Mid-Atlantic.
Yeah. Okay. So you can, with both satellites, we can get 4 60-second mesoscales, or you can request them as 1 30-second mesoscale. So we in the team like to call this weather TV. You can also get a different mode where you take the mesoscale capability away and put the entire satellite into, and you give up CONUS. So instead of 10-minute full disk and 5-minute CONUS and the 2 mesoscales, you get 1 full disk image every 5 minutes. So the tool allows for those selections to be made and the timing of those selections to be made and the justification for why you need those selections to be made. And it facilitates the workflow of forecast offices making the request and the SDM brokering the request and the NESDIS help desk facilitating the request to the satellite operators at NESDIS that actually implement the request. So the SDM gets to create the plan and so forth. All right, next chart. Now, why is this tool important? I guess I already kind of briefed this. Goes NOP, you either had RSO or you didn't. Here we have all kind of cool stuff. So this is the idea here is this is not just more RSO. This whole independently targetable thing is a new game. And we fully expect, by the way, I'm going to say this for a second time because it's really important. What we're doing now with this tool will hopefully have no resemblance to what we're doing 3 years from now with this tool. We think that the CONOP for using mesoscales, as people learn what they can do with the imagery, what kind of things they see in it, there will be hopefully all kind of creative utility of this. And the idea is that this tool should not constrain new CONOP development. It should promote it and further it. And so that's the pitch. All right, next chart. This is what it looks like. For those of you that have never seen it, if you notice that globe looks very, for those in the JavaScript, it's d3.js the little engine that's doing the graphics, and this is showing the world from the perspective of goes east. And so from that perspective, the goes 16 mesos look like squares, and the goes 17 mesos look like they're draped over the Earth from somewhere else. So on the left, you got a timeline. The time goes up, so the stuff in blue already happened. The stuff in orange is going to happen, and orange and green. And if you were to hover over different areas in there, you would see the little mesos move around, so you get an idea of what's going to happen, what happened, or what's going to happen and when. All right, next chart. If you are of the forecaster persuasion and have access to make requests, then you would be able to pull up a screen that looks like this, which allows you to make requests of the timeline. You put requests on the timeline for 30-second, 60-second, mode 4, or the scan mode, and put in your, there's what, 40 justifications? 26 now, okay. Oh, down to 24, okay. 24 different justifications ranging from, what's number 1?
SPC, high moderate risk.
And what's number 24?
DOD.
Yeah, okay, so, and that's how it ought to be, right? Okay.
What do you mean by justification?
So if a forecaster wants to place a meso, if what's number 13?
I think it's her tropical storm watch.
Okay, so who would make that request?
The Hurricane Center.
Okay, so the Hurricane Center says we want to put one of these mesos over an area where we got a tropical
storm
watch, right? And so they're going to get it, except if SPC comes along and says, no, I've got a severe weather outbreak in Kansas. So they're going to put in a justification that's number 1, and it's going to trump number 13.
It's the reason for the request.
Yeah, it's the rationale for
that's justification.
Yeah, so if you have conflicting requests, that's your deconfliction process for who's going to get it.
But you got 2 sectors
per satellite. Right. So they are somewhat regionally. You get 2 that see the coverage area of goes east, and 2 that see the coverage area goes west. Okay, next chart. All right. So the request process, again, it starts out with requesting entities, using the tool and putting in requests. The SDM gets an email notification from the tool. It also shows up in the tool and deconflicts, again, using those priorities and their own intuition and whatever else the SDM wants to bring to the table. They decide what the actual plan is going to be, and they're continually updating the plan out. How many hours?
We go out to 60 hours.
You guys can tell who really knows what's going on here. That's Eric with all the answers. So the SDM coordinates a plan out to that many hours. Once they lock in that, every time they update the plan, an email notification goes to the NESDIS OSPO help desk, and they are our entree point, our focal point into the into NESDIS operations. They communicate with OSPO satellite operations, and the SOC actually schedules and uplinks and controls the satellite at the right times to actually move the mouse. All right. So that's the CONOP, and that I think we're going to talk about the coordination team. So I'll leave that for a chart, a couple minutes. The MM. So what we said is we want this triple M tool or the MDS tool to be very agile, forward-leaning, change-friendly, agent of change, all that stuff. So if you're going to do that, you can either be really buggy and then everybody will stop using it and all that, or you can come up with a good governance mechanism and for change management and revision control and those kind of things. And this is what that is. We are the dev org in the Weather Service Office Observations. We support the MDS core team, which is headed by Mike Betwee of the Weather Service Operations Division. The core team has membership. This is an IPT with Weather Service regional focal points. Frank, I think you're on that. Is Frank on that team? No, Frank's not on that team. Sorry, Frank. Weather Service regional focal points, the national centers, the Ops Center, and NESDIS all have representation, and they're deciding things like what the priorities ought to be, whether we got the right priorities. They're also making requested changes and upgrades to the tool, to the ConOp, to all those things. In fact, right now we're going through an Eastern Region test of currently the tool is used by a subset of the forecaster workforce, and there's some intra-region consolidation before it gets to the SDM. Eastern Region is now doing a test where every forecaster at every office is able to independently make their own requests, and that's really the next thing that we see happening across the board. But there's disagreement across the community as to whether that's the way we want to do it or not, and so this is the evolution. This is the change process that we're trying to go through. So the MDS core team meets on a monthly basis to discuss these issues and deal with bugs and suggested improvements. The MM tool developer, which at the moment is me, we're lucky to have a fellow named Lamar Jiggets on the team for the last year, and he did a lot of the JavaScript heavy lifting, and hopefully we'll have a new person dedicated to that role soon, but for the moment, I'm the man. And we implement and test changes to the tool before we deploy them and inflict them on the community. Changes are applied either on a monthly development cycle or if there's bug fix as fast as we can. All right, next chart. Okay, so that's kind of some context of the tool and what it's for and how it's used and who coordinates it and all that. Now, how does it work and where does it live? So it's all about, since this forum, it's all about the virtual lab. So, next chart. As you know, the VLab is a know-why content management system that Steve has brought into existence over the last,
6, 7 years.
Almost decade now. And it runs on IDP in College Park. It's an instance, the part that we care about is the VLab collaboration server, right? The VLCS, which is the LifeRay platform, and that provides tools for creating custom content. And it, thanks to the work of Ken and Jason, got an Elasticsearch database, which is really an enabler for this project, strapped onto the side. And we believe that, and I think maybe we've demonstrated, it provides an infrastructure for fast and simple and reliable development. So next chart. So there are some components to, you know what, this was in response to the concerns of a senior manager that we won't name. So Elasticsearch, Ken and Jason configured it and designed it so that there's some backup capability and reliability to it, and we found it to be very backed up and very reliable, and life's good. VLab in College Park IDP basically works as well as College Park IDP works. Whenever you get a chance to repeat that to senior management, please do.
Yeah.
We got backups going on. You got all kind of things to make sure that things work reliably. And again, they do, except for when IDP melts down, and then it doesn't. It hasn't in a while, so life is good. All right, next chart. User authentication. We got authentication now through NodeEcho VLDAP. There's all you guys got POAMs, and we're following the various security rules for what is it, a moderate or a low, but you're in the
high.
Oh, we're in high. So you're following rules, and we don't have to because you guys got it covered. And we've got this multi-layer, multi-level security administration for applications, allows for assigning roles. We exploit that for dealing with who's allowed to make changes to, make requests, who's allowed to see the requests, who's public and can't see anything. And so all that, what you got is all the hard work's already done. All we have to do is the application. Access controls. I just said this. Who can update the Elasticsearch? Who can get the documents? Who can get the web content? Users and groups. Custom roles. Basically, the whole framework for presenting a rich, interactive, secure, multi-level, reliable capability is already there. So that doing an application like this, all you have to worry about is the application, and that's the thesis. Please repeat that to anybody up in management, because I think it's an incredibly powerful environment that for rapidly getting operational grade capability out into the forecast community. All right, next chart. We use JSON Web Services to talk to the Elasticsearch from. So the way this, I guess, let's talk about the way this works now. This application is used, as far as the VLab is concerned, it's user content. It's just a document. There's a web content portlet, and it's got JavaScript in it. That's it. So there's no having to go into IDP release cycles or code changes. It's just user content. The user content, because of the structure of things that Jason came up with, is able to talk to this Elasticsearch database over JSON Web Services, and so the database is what carries all the request information and the history and all those kind of things. And it's a JavaScript application, does AJAX calls to the Elasticsearch, and so we're able to provide this kind of rich, integrated looking capability, basically as user, but from the VLab and system perspective, it's just user content. It's just a document. Okay, next chart. Another feature of the VLab is the forums. We think about them for discussion forums. Is AWIPS 2 Dev actually a VLab forum under the hood now? Okay, so you think about it for doing stuff like that. What we used it for is it's the great dichotomy of what we want to do is send emails out to people that we want to send emails out to, but we also want to let people subscribe to those emails for notifications, and we don't want to get into the business of writing emails. So we just had, the JavaScript environment. If you're user content in the VLab, you got JavaScript calls that can talk the API to talk to the forums, and all you have to do is post to the forums. So that's another interface we don't have to worry about. Again, user content. So we use the forums to send these notifications out to as confirmation back to requesters, as the trigger notifications to the SDM. It's how Nesdis is notified, and so there's a key component of the capability. The neat thing about it is that the email goes off, but there's the forum post sitting there, so you actually have a history right there in place. It's very easy for anybody to go query to see what happened, when it happened, and so forth. All right, next chart. Okay, so those are the pieces of those are the kind of the pieces of the VLab we use. Again, I'll say it one more time. It's just user content. The VLab had all the hard parts in it. All right, so implementing in that virtual lab, although I've kind of been talking about that. Lamar wrote this, and actually I should say Brian Rapp wrote the original version. That was pretty cool because he didn't know JavaScript, and so he learned JavaScript and wrote the original thing, and it worked. And then we brought Lamar in, and he was a JavaScript guy, and so then he did it right. So he used it's a React.js based application. He used Babel. He used jQuery for the user interface. D3.js for the graphical stuff. AJAX obviously to talk to Elasticsearch. For development on offline, he used npm and Node.js for his package management and offline as an offline engine for doing the development. All right, that's a whole lot of packages. I know about 3 of them by now. I'm hoping to get maybe 3.5 and then get somebody else to do this. Let's go next chart. Now, the other point, there's some Python going on. This user content talks to the Elasticsearch engine, but you might have asked, well, how does it know what actually happened after we put the request in? Well, we have these systems out at AWC, NHC, OPC, IDP, Boulder and that are called ISATs, and they're actually processing GOES 16 and 17 imagery. So those systems are written in Python. They get the data off of the GOES-R GRB antennas that are at those sites, and in doing their work, they detect when a mode changes or a meso is targeted. And every time that one of those changes occurs, they send a little message to the VLab via web services, Python web services, and insert it into the Elasticsearch. This is another thing where the VLab, how it's positioned within the weather service operational community, where you can get at it from AWIPS, the AWIPS network as a web page. You can get at it from the national centers or from the outside world with appropriate security controls to be able to communicate message content with this Elasticsearch database allows for a loosely integrated system to be put together, again, with very little coordination. You know, you don't have to design the whole thing and all the rest of that. You got these established interfaces, and using modern protocols and what do you call it, Jason? Data standards for semi-structured data, be able to put things together like this. So in Python, there's this backend script within ISATs that forwards these messages, and then okay, he's talking about, yeah, we use Git, we use the VLab to control the code that we put on the VLab to do this. So you're kind of all in one. All right, next chart. Development workflow. Oh, this is boring. We create a branch, we test it locally, we use VLab Dev to test it out. We give it to Eric, he tries to break it, he can't break it, and then we merge it onto the master, and then we deploy it. Next chart. Well, I'm sorry, we create a tag, then we write release notes, we upload to production server, we call the SDM, and we call Ken or Jason, we make sure we didn't break anything, and then we rock one. And again, that can happen asynchronously with anything big happening to the VLab because it's just user content. All right, next chart. Version control. We are version 2. I don't know, sooner or later, we'll decide to do something radical. We'll call it version 3, but then you got year, month, and iteration. We use tags in the Git repo to mark versions because we're on the trunk. And there's release notes on there's a VLCS page for maintenance of this code. Okay. Again, I've been kind of talking this through and through, but what did we use out of the VLab to do this thing? One, the file manager. So there's JavaScript libraries and modules that are uploaded as files to the document repository. We use the heck out of the authentication and user management, logins, roles, community memberships. The Elasticsearch is kind of the key to the whole thing in terms of data persistence. We're basing everything on the security of of the VLab within a FISMA high server. We use the web content portlet and all its schemas and setups, and we use the forums. Okay, so basically, if you're going to write any web application and try and deploy it, before you even start, you're going to do those 6 things, and then you get to the fun part. So I should have had a picture of a pyramid here because picture the pyramid, like on the dollar bill. All we did is little eye on top, right? What Jason and Ken and all you guys did is the heavy lifting of the rest of it.
I like that.
Okay. All right. Next chart. Oh, I don't like this diagram. So this kind of talks. I don't want to brief this diagram. Go to the next chart. Conclusion. So GOES 16 and 17 have these 1-minute mesos, 4 of them. Brave new world. We got to figure out how to fully exploit them. They were about $1 billion worth of capability. We ought to use them. The M tool provides workflow for fully utilizing and coordinating the forecast workforce in managing that asset. Provides a central location for collaboration this would be a lot easier if all the weather service worked on the 4th floor of this building, which is kind of what Nesbitt thinks, by the way. I think it's kind of funny. But because it's we're dealing with a widely geographically dispersed community, being able to have this kind of central portal where we can not only have the tool hosted, but documentation about the tool, updates, instructions, all that kind of stuff is a big deal. We hope that you think the tool is flexible. So far, it's been pretty extensible. And Ken and Jason, I hope you guys think that it's not a big impact on your system, because we want to do stuff like this again. And as far as we're concerned, VLab this is the platform for doing this kind of work. I mean, anybody that is a skeptic on how enabling this is and what the cost savings are, we really need to get them in a room and work them over, because this is, as far as I'm concerned, we've got an operational capability there, and the 1 weak link may be that you got to be on an operational grade platform, and to the degree that you can get there, everything else about it is just perfect. The connectivities, the basic set of features. I'm not going to stroke those guys. The support guys are all right. And so that's the pitch. How am I doing on time?
You're perfect.
All right. You hear that? I'm perfect. Okay. And when do you have to leave?
1 minute.
Oh, okay. So let's start with questions for Eric.
Yeah. So thanks, Joe. So now we are at the question part of our session. So we got two chatted questions. What are numbers 2 through 4?
Uh-oh. He's talking about priorities?
Priorities. Eric is racking his brain.
2 is a volcanic eruption in the United States. 3 is an SPC enhanced risk. And 4 is a hurricane warning.
There you go.
Wow.
There you go. Whoa.
What was 1 again?
1 is an SPC high moderate risk.
All right, second question. The OPG would like to see a history of MDS locations going back much longer. Is this capability part of the plan? Matt Foster.
For you, Matt, yes.
All right, you heard that, Matt? For you, they'll do anything, apparently. Or at least that. Unmuting Ken Johnson. Ken, go. You're on the air.
Oh, thank you. Thank you.
Wow.
Good presentation. All you guys, got to admit, I'm not familiar with a lot of the lingo, so the past few slides, maybe I need to do a little bit more learning. However, a comment and a question. First comment is, this particular capability that you developed has been extremely useful, and as you probably know, in Eastern Region, we're trying to use it to its what we feel is its ultimate use, which is to have the forecast offices be able to directly request the position of the mesoscale domain sectors without having to go through Eastern Region or the operations center and so forth. So we're starting that experiment now, and this is, we couldn't do this, I don't think, without this capability that you developed. So I want to thank you for that. However, if you could do me one favor, I would really appreciate it, and that is change the save button to be a submit button. I'm hesitant nowadays clicking on anything that might save if I don't know what's going to be saved. And so when making a request, if we could have that button be labeled as submit rather than save, I think it might help with some confusion or concern. So that's the comment. And the question, you ended this by kind of alluding to the idea that VLab could be used for a lot of purposes like what you've done here with the satellite. And I was wondering if you had thoughts on what some of those other applications or those other areas might be.
Wow.
Oh, big smile on Joe's face for that, Ken. Go ahead, Joe.
Absolutely. Okay, so the first one, we believe that this Elasticsearch kind of capability coupled with D3 graphics, we can do monitoring of data flow. One of the things that we've experienced in the satellite business is all of the value chains to forecast offices tend to be pretty long. You know, for instance, if you look at how does the GOES-R sectorized CMI, the imagery, get to a WFO? Well, it starts at Wallops Island. It gets produced, it gets imaged by the satellite, goes down to Wallops, back up to the satellite, back, no, it's direct now. From Wallops, it traverses a link over N-Wave to get to the NCF. At the NCF, it gets up on SBN. At SBN, it gets to, to each individual center or each individual WFO. There is the possibility for, at the national centers, they each have their own GRB antennas. And this is kind of a long wind up here, but I'm going to swing in a minute. They each have their own GRB antennas, and they're doing the same processing, but independently. And so we've seen a lot of cases of, is the problem me, or is it upstream? Does he have the problem that I'm having? What's going on? And so we believe that, in the same way that we're sending status updates from the ISAT systems to the Elasticsearch on what the meso changes are, we could just as easily be sending little status messages from all over the place on what data is coming in and what's going on. Sort of like a universal Big Brother, and provide some centralized kind of fleet-wide monitoring of various data flows, so that people would have a quick reference to go, is it me? Do I need to call my ITO? Do I need to call the NCF? Does somebody need to call NESDIS? What's the end-to-end flows look like? So that's one application off the top. Similarly, one of the things that we thought that we might want to be able to play with is we've got and it's just this geostationary data is kind of easy and intuitive for forecasters to understand, because we keep imaging the same area over and over again. Like I said, weather TV, right? You start dealing with polar data, and the darn orbit is a little more complicated. The Earth keeps spinning out from under the orbit, so nothing's ever the same, and things don't happen very often, and it's a little less intuitive to understand, what's being imaged where and when and so forth. So one of the things we were thinking about doing actually on this application is providing a Where's Waldo display. We've got a timeline. The good news is, because of physics, we know pretty much where the satellite's going to be in the past and in the future, and so we can show where the different constellation of satellites that have data of interest to the forecast community might be, and show that, again, with a very minimal amount of JavaScript and the resources that are there. Another area similar to that, and in the nature of the thing I was talking about troubleshooting before, NESDIS puts out a lot of messages about when their system's going to be down, and when there's going to be an interruption in data flow and those kind of things. It seems that there are some segment of the weather service community that are in the know and kind of into it and get the messages, and a lot more that are really focused on forecasting the weather and don't see that. Well, one of the things that we hope, especially Ken, with what you're what your region's doing, where this would be a display that gets glanced at maybe more often than not because everybody's using it, is we could project that kind of messaging of, hey, on that timeline, when are the projected, if there's an outage and we know it's going to happen, let's make sure your forecasters know about it in a way that that brings it to them, doesn't have to make them go look for it. There are also, and these are kind of satellite-ish sort of things. Another arena that I really don't have an application for up front, but that we were thinking about more for the satellite world, we're collecting SBN, and some of these things you go, yeah, I don't care about that. This is not interesting to me. But just to give you the idea of the kind of things that we could do, and there'd be more mission application, but similar kind of things to do. You guys put out watches, warning, all kind of graphical watches, warnings, things going on. I'm kind of an outsider, even though I've been sitting with you guys for 5 years now, something like that. This whole forecasting apparatus, I'm kind of learning how it all comes together, and being able to say watches and warnings and outlooks and all that stuff. I don't know, I made a joke earlier, but you go to NESDIS, and literally at the program office, they thought that AWIPS was the system on the fourth floor of SMC2. The ebb and flow that you guys live in every day of watches and warnings and CWAs and things going on really isn't something that impacts their daily life. But they're there to support you. Their whole world, not their whole world, because they would say that they support ocean service and fisheries and Coast Watch and all that stuff. But a big part of the NESDIS's world, the satellite world, is supporting this mission, but they don't have it in their blood because they're not in a forecast context the other day. And I was looking at it and going, man, these watching these little, I saw some display where the watch areas were and warning areas were moving along as weather and stuff moved along. And I went, wow, that's kind of the output of the Weather Service. That wouldn't be hard to throw on that display and that timeline. And if we did that, it might communicate it to some of those satellite-ish NESDIS people that don't necessarily see that stuff. And so it might be a way to composite something that they do and care about that's in their world with something that we kind of want to influence them and bring it into their world. And so in the lab, we have an SBN link, and we're kind of what do you call it? Tracking all we're doing statistics using another instance of Elasticsearch of all the products coming in and what's going on. And so if I ever get a couple minutes, we're going to scrape the actual watches and warnings and stuff and throw them up onto this display and see what it looks like. Another thing, same way we're pulling statistics off of, or the mode changes and that kind of stuff off of ISATs, we can also pull actual data statistics off of the data, averages. For instance, during the loop heat pipe episodes, we had a little tool that is measuring the average radiance across the entire field in those bands versus time, and you can actually watch the thing heat up, in a kind of telemetry trace kind of way. So I think that anything that looks like that can be represented in a telemetry trace or scatter plot or data collection kind of activity, the richness of the JavaScript libraries and this means of delivering content could be used to render that information and reach the entire forecast. So I kind of rambled on for about 5 minutes, but did that give you a flavor for the kind of things I could envision doing? I'm not suggesting that's stuff that you're interested in. I'd be really interested in hearing your thoughts on how those kind of things where you're collecting data from lots of different places and wanting to concentrate it in a web viewable place.
Now, this sounds great. You know, your Where's Waldo thing. In fact, I thought about that this morning as I was looking at the mesoscale domain sectors, saying, gee, you know, is there a way that we could apply this to the polar orbiters as well? So I'm looking forward to, if you have a chance of developing something like that, to take a look at it and test it out. Your comments about you know, all the watches, warnings, and so forth. There's probably at least a half a dozen places that I know of where you can go look at some of that. But you know, if you could bring it all together, particularly to help those who don't necessarily see or understand the Weather Service mission, that would be a great thing to do. You know, many of these are very interesting and I think very good. And if you can leverage VLab to do that, that would be great. But I'm particularly looking forward to your Where's Waldo thing.
Okay. All right. And yeah, Eric says I can do that button for you once I figure out how to do it without screwing things up.
Okay, I'm sure you'll be able to figure it out.
All right. Thanks, Ken, very much. So we got a couple of chatted questions here from Thomas Grafenauer. In Central Region, we currently need to provide a central lat long point in the request. If it is ultimately up to the SDM for center point, is it necessary to provide this? Question. It can be difficult to mentally visualize how the domain will encompass an area on a curved Earth, thus choose an appropriate lat long. Any thoughts or plans to address this difficulty?
Is the concern with the projection that we're using to present the, I tell you what, I don't know how to answer the question right off. Can you forward me that question? Thomas, we'll have Eric Gillot contact you tomorrow and get down to the details. I'm sure that we can figure out how to best support.
And he adds this can be especially difficult when the requester's office is on the edge of a threat area or domain sector.
Yeah, this is probably a projection type kind of thing. Yep.
All righty. And
where is
Tom?
Mr. Grafenauer? Where's Tom?
Yeah, Tom. Maybe you could chat which office you're with. You're in Central Region.
I've seen his name before. I just don't.
While he's Grand Forks. Okay, there you go. The Great High Plains. All right, so they're going to get back with you, Tom, on that. Mark McKinley says, in the future, could there be an application that looks at change in cloud top temperature and automate where to place a meso window?
Sweet. We're excited for all kind of ideas like that. I would defer that to Mike Betwee, is the coordinator of the IPT. I am a huge cheerleader for exactly, not necessarily that specific concept, but the notion of, you know, something other than a forecaster says, yeah, why don't we put one over here? One of the things that we're currently working with Mike on is a plan of the day based placement of these. Right now, the default is that you park them over 4 places by default, and while that's really good for the people that are under where they're parked, there are probably many phenomena where if a forecaster doesn't request, it's not going to happen, and so the one area is, could we, you know, use model or man in the loop, you know, day before planning? I mean, and I'm really the wrong guy to talk beyond the generalities here, but you know, you got models that are forecasting out what's going to happen multiple days in general. You got national centers, which are where you, best I can tell. And again, this is Joe the engineer watching you guys work. I see Mike Fulmer sitting in front of a screen at OPC, you know, in front of what's the GFE, you know, tweaking grids, you know, 4 times a day as to what they think is going to happen in 24 hours. And I know that Eric and company are, and I know SPC is starting to do some of this on fire weather, some other stuff where they're actually laying in a default plan for where the mesos are going to be. Now, I think what Mr. McKinley's talking about is actually a more closed loop kind of tracking kind of scheme.
Yeah. So his question kind of leads into where I was going to ask as well in terms of so how agile is this sector itself? I mean, how quickly can a new one be defined, and what's the shortest
Technically,
duration that it can be in place?
I don't know if
Are you going to be moving all the time? You know.
Well, I don't know whether anybody remembers back to when they were doing CalVal on Go 16 and Go 17, intensive CalVal on Go, but there were days when they would go into what we like to call hypermeso mode, and they would change these things once a minute, because what they were doing is grabbing landmarks at all these different locations along the coast, and you would see the thing just go. You know, if you ran a loop of the on AWIPS 2, you would watch the mesos just walk the coast.
So it's all done from the software standpoint at the satellite. It's not a mechanical thing moving. It's just.
Oh yeah, it's not a phased array. It's an actual telescope that's moving. And remember, when you're looping and your time compression ratio is 300 frames in 30 seconds, right? You know, the thing's actually sitting there for a minute or 30 seconds at a time. So it's, but yes, you could theoretically, and actually they've done it, move this thing once a minute. I think in terms of anything that we're doing now, I think once an hour is probably as good as we're going to get without really making the apparatus we have now, which is we've got this website that's doing, we're in the computer world and leading to questions like Mr. McKinley's, which I think is forward-looking. But it breaks down when the way that connects to Nessus right now is an email to their help desk, which then gets turned around by a help desk operator to their satellite operator. But come up with a killer app and then let's solve the problem. But I think we should absolutely be thinking about ideas like this and precedent. I think that we should be thinking right now. The use of the mesos is geared towards sit and stare type use, right? Because that's kind of what AWIPS is geared toward. Is I'm going to place the thing and then watch it loop, right? Well, in the same way that GoSmart gives us higher spatial resolution in a single image, one could think about I've got one 15-minute or 10-minute image, but I've got 10 minutes worth of texture. And instead of looping through it, I could do math on it and come up with one answer based on doing various averaging, filtering, and so forth on on 10 meso images. Not so much to watch something move, but maybe to enhance something, a signal that's low SNR, or reject something, I'm a signals guy, but an interferer, or those kind of things.
Mm-hmm.
So I think that there might be applications where I don't need to sit and stare. I just want to go sample something for 15 minutes or half an hour and then go off and do something else. So I think that there's a wide opportunity for creativity in using this asset that is going to take hopefully people that the power of the Weather Service is you got 150 spatially diverse, highly educated, highly motivated small teams, right? And that's where that are mission immersed, right? And that's where creativity has the best chance of happening. And so our position on this thing is how do we stimulate the out of the box thinking? Well, it's cliche, but creative thought, and let's try those things.
Okay. John, do we have any other questions on the line? If you'd like to ask, we have a few minutes to chat in a question or raise your hand. So I know we've been walking this sort of fine line well between VLab supporting prototyping and collaboration and development and so forth, and something that is considered to be a key operational application. So where does this stand now? Are you guys looking at, any particular solutions at the moment that harden this? Joe's shaking his head. Okay. Well, that's fine. That's fine.
What's the right answer?
There's no right answer.
We think this is a beautiful thing.
I know. It is a beautiful thing, and the check's in the mail, Joe. John's going to be reviewing the recording for these audio clips, sound bites for VLab promotion. So that's fine. Okay, well,
I'm just a contractor help.
I know you are. You are not an official rep of the Office of Observation. So, but this is great for exposing the capabilities of these tools, which you and only a few others in the VLab universe have done, and you guys have gone far beyond any others. So, and it does require that, right? These things are available, and it is a source of some pretty cool applications that are sort of right out of the box, more or less, as it goes. Let's put it that way. That could be further exploited for other things that can, ask that astute question about. So, so we want to encourage folks to do those sorts of things. That's part of VLab's mission, is to have people try stuff, right? You don't have to whip out a purchase card to do that. You just kind of use the tools, and you can call the VLab support team if you get hung up or don't know what to do, or they can forward you over to Joe to help troubleshoot in his spare time, of which he has none. But that all said, this is what part of the mission of the Office of Science and Technology Integration is to promote this kind of stuff that we could use and potentially greatly improve our mission capabilities. So this, I think, is like a really fantastic example of that. There was this, big, expensive new satellites going up and brand new capabilities. We're at the tip of the iceberg exploiting them, but Joe and his team have exploited, the new mesosector capabilities and used the VLab to drive the exploitation of those capabilities for this important mission. So, all right. Well, with that, we will call it a session. That's a wrap. Thanks, everyone. Coming up in July 17th, we got Carrie Sheets from the Office of Dissemination going to talk about the NWS GIS Viewer, which is a big new project, also destined for IDP, like VLab, and and there's a lot of interest in that. So we invited Carrie to kind of get more background. I know they're just getting on board hiring folks to start working on this seriously. So it should be a good session where you can ask a lot of questions and hopefully get a lot of answers to them. So with that, we all sign off. Thank you, Joe, as usual. And we will see everyone in July, hopefully. Take care.